Hello everyone and welcome to this section. In this section, we're going to cover a lot of interesting topics. Mainly, we're going to cover the feature detection, okay? Which is a very important kind of strategy we're going to be using to analyze images and detect, for example, objects, detect corners within an image, detect different colors within an image, and so on and so forth, which is very important in general for self-driving cars, for car or vehicle detection and pedestrian detection as well. Okay, so let's get started with the first lecture on just quick introduction on image features. Okay, so what do we actually mean by feature? So a feature is simply an important area within an image that has kind of a specific or unique characteristics within an image. What do you mean? So within this specific image, well, the area here within that truck looks very different than, for example, the sky around it, for instance. Okay. Look at this region, for example. It has maybe like, that's kind of the hood of the vehicle. And that's pretty much all what we're looking for within an image. We're looking, for example, for unique features like color, for example. Here, this is, the hood of the vehicle is kind of blue, which is indicating something is a little bit different, something a little bit interesting within an image that's different from all that, like kind of boring gray, or maybe different blue and white color indicating the sky with these clouds, and so on and so forth. Okay, so a feature is a piece of information within an image, such as points or objects. They're kind of unique or different. All right, a feature again can be a color, can be an edge detected. So again, this is my image, and this is kind of my kind of canny edge detection. That's pretty much, like it shows the interesting stuff within the image. It shows that there is, kind of all these are kind of edges indicating there's a truck in here. All these kind of edges indicating something, a building or the tree or whatever. And here kind of, some edges indicating lanes. And that's kind of the most interesting stuff within the image. However, here we didn't care. Here it just shows black. Here it shows just completely black. Why? Because it's kind of boring within the image. It's like, all have the same color. There's no difference in intensities within the image, and so on and so forth. Okay, that's pretty much how can we use features to extract information within the image, and then we can say, okay, what that information might mean. It might mean a pedestrian, might mean a car, might mean whatever. Okay, a good feature has to be repeatable, which means if, for instance, I'm extracting features of a vehicle, okay, that need to be repeatable, which means if I see, like any car from the back, okay, if I see the exact same car from the back, or I see any image of a different kind of brand of a car from the back, the car features are repeatable within different scenes, okay, and that's the beauty of what we call it. One of the features we're going to be discussing. Or techniques we're going to be discussing later on, so call it hog features, call it histogram of oriented gradients, which is kind of a very fascinating technique that we could use to actually give us the features of a vehicle, and then we can use it afterwards to train a classifier, to train a support vector machine classifier, or to train whatever network to actually detect, okay, when I see this, that means a car. I'm going to show you later on, all right? Okay. This is kind of, like an algorithm as well, feature detection algorithm, going to call it FAST, and I'm going to cover it as well in this section. Just shows you, like, once you run it, will show you, okay, different circles here indicating these are kind of the interesting areas, interesting regions within an image, okay? Again, this is kind of different techniques can be used for feature detection, all right? Okay. So again, why are features important? As I mentioned, we could get all the different features, okay, from different images, from different truck images, for instance. So if I have, let's say, this truck, I can classify them with colors, for instance. I can say, okay, a truck might have white color, or maybe have red color, or maybe have, for example, like yellow color, or maybe in the actual body of the truck, it has all of them are white color, for example. But that's very difficult because the variation is very, very different. So we're going to learn how to do feature extraction using colors or using histogram of colors. However, this technique is just, you can use it, but you can't rely on it because, we need kind of more advanced form to actually tell you, okay, these are the features of the truck, all right? So we're going to take all these features. What we're going to do, we're going to take them all. We're going to train a machine learning algorithm, okay, such as support vector machines, or an artificial neural network, for example, to extract all that information and tell us, okay, when I see these features, when I see any of these features, I'm going to say that this is for sure a truck, okay, with a specific, obviously, like confidence interval, okay? So image features are critical in machine learning and self-driving cars because they can be used to analyze, describe, and match images. Features can be used to train a classifier to detect objects such as pedestrians and cars, all right? And that's pretty much why do we need features, and that's pretty much why we're gonna be covering this like a very interesting section. I hope you guys enjoyed that section, and see you in the next one.